raw bison hides arrive in heavy, salted bundles. The first job of a modern bison leather factory is to stop biology from winning. A hide is mostly collagen, fat, and water, and if bacteria get time, they digest the collagen structure that gives leather strength. That's why the receiving dock behaves like cold logistics. Every bundle is weighed, tagged for traceability back to plant and date, checked for cure quality, and moved quickly into controlled storage. Bison hides are not a copy-paste version of cowhide. They're typically thicker, with more pronounced grain, more natural scars from brush and fences, wider variation across the hide because bison live harder. That variability is exactly what luxury brands pay for, but it's also what the factory must engineer around. Because uneven thickness and dense fiber zones can tan unevenly, dry unevenly, and finish unevenly if the line isn't tightly controlled. The first production stage is rehydration and cleaning. Salt-cured hides are stiff and dehydrated. So they go into large rotating soak drums with water, wetting agents, and bactericides. The drum's rotation speed and water chemistry matter. Too aggressive, and you mechanically damage grain to gentle. And salt and dirt remain trapped. The plant monitors conductivity of the soak liquor because that tells you how much salt is leaving the hide. It controls temperature because warm soaks accelerate bacteria. After soaking comes hair removal. For most fashion leather, this is liming, and it's chemistry plus mechanical prep. In liming drums, the hides are treated with alkaline solutions. It's often lime and sulfides, to swell the fiber structure and break down hair follicles so hair can be removed. The factory controls pH, time, and agitation because liming opens the hide, but overlimbing weakens the grain layer and creates loose, wrinkly leather. Bison's thickness can tempt longer liming. But high-end operations prefer optimized chemical penetration rather than brute time, because time increases grain damage risk. Once the hair is loosened, the hides go through unhairing and scudding. Machines. These are high-torque rollers and blades that physically remove hair and epidermis without cutting into the dermis. Pressure control is critical because bison grain can be more textured and uneven. Too much pressure cuts the surface and creates defects that no finish can fully hide. At this point, the factory separates product paths. If it's making hair and bison for rugs or specialty panels, the process changes early and preserves hair. With different chemistry, for luxury fashion leather, the hair-off route continues into fleshing, where a fleshing machine removes fat and membrane tissue from the flesh side. This step is pure mechanics. A spinning cylinder with helical blades skims the hide thickness to a consistent baseline. Removing fat is not cosmetic. Fat blocks chemical penetration, causes greasy patches, and later leads to rancid odor and finished delamination. Now thickness control becomes a factory-level performance metric. Bison hides can be thick enough that splitting is required. A band knife. Splitting machine slices the hide horizontally into a top grain layer and a split layer. The top grain becomes premium leather. Splits can become suede or coated leather. Split thickness is measured continuously. As fashion production needs predictable thickness for stitching, folding, and edge finishing. Modern lines use inline thickness gauges and tight calibration schedules because a small drift in thickness turns into big drift in feel and yield after liming. The hide is too alkaline to tan, so it goes through delemming and baiting. Delemming gradually lowers alkalinity, often using ammonium-free systems in modern plants to reduce emissions. Baiting uses enzymes to remove non-collagen proteins and refine softness. This is where hand feel begins. Baiting controls how cleanly fibers separate and flex. Too much enzyme action can weaken grain and exaggerate bison's natural marks. Its little leaves the leather stiff and bore dye. Next is pickling, which shifts the hide into an acidic condition so tanning agents penetrate correctly. Pickle drums add salt and acid to bring pH down in a controlled curve. And this curve is monitored because pH is the steering wheel for the next step. Inline pH probes, temperature sensors, and dosing pumps keep the pickle stable. Because inconsistent pickle means inconsistent tanning. And inconsistent tanning shows up later as uneven dye and variable tensile strength across the batch. Tanning is the chemical conversion that turns collagen into a stable material that won't rot, shrink, or gelatinize in heat and moisture. The fastest, most common method is chrome tanning, using chromium-3 salts and rotating drums. The drum is doing two jobs simultaneously. It's moving chemical through the hide and keeping penetration uniform across thousands of square feet of material. The factory controls float ratio, drum speed, tanning time, and then the critical step called basification, where pH is raised carefully, so chromium bonds inside the collagen matrix. Raise pH too fast, and chrome precipitates at the surface, leaving the center under-tanned. Raise it to slow, and you waste time and energy. Luxury factories increasingly offer chrome-free or low-chrome options for certain markets, which can mean vegetable tanning, aldehyde tanning, or hybrid systems. Vegetable tanning uses plant polyphenols that build a firmer, more structured leather with a different aging character. It's slower and requires careful control of concentration. Gradients to avoid case hardening, where the surface gets to tanned and blocks deeper penetration. Hybrid processes combine speed and performance by using an initial tan for stabilization and a retin for hand feel. Dye depth and firmness. Once tanned, the hides are wet blue if chrome tanned, or wet white if chrome free, and the factory now shifts from preservation to engineering luxury characteristics. The hides are pressed or sammed to remove water efficiently. Hydraulic setting out machines squeeze and flatten the hide, removing wrinkles and aligning fibers. This mechanical flattening improves yield because a flatter hide gives more usable cutting area for fashion patterns. Shaving is next, and it's where thickness becomes precision. A shaving machine uses a rotating blade cylinder to shave the leather to an exact final thickness, often within tenths of a millimeter. Luxury goods demand consistency because thin areas feel cheap, and thick areas won't fold cleanly. Shaving also determines how the leather takes dye and finish, because chemical uptake changes with thickness. Then comes retanning, dyeing, and fat lacquering, usually in the same drum type but with different chemical recipes. Retanning modifies structure. It can add body, improve fullness, and refine grain tightness. Dyeing is controlled penetration and shade matching. Fat lacquering reintroduces lubricating oils so the leather flexes without cracking and feels supple. This stage is where high-tech control becomes obvious. Factory monitors pH, temperature, and time like a chemical plant because dyes and oils behave differently depending on acidity and fiber openness. Color matching is not done by eye alone. At scale, premium operations pull lab dips from each lot, measure color with spectrophotometers under standardized light sources, and compare results to digital targets. If a shade is drifting, they adjust with controlled additions, because a small delta in dye concentration is amplified across thousands of hides. Bison's natural variation in grain and porosity makes this harder than cowhide. The process control has to be tighter to hit luxury uniformity without burying the natural character. After wet processing, the hides must be dried, and drying is another place where leather can be ruined by shortcuts. Hang drying is gentle, but slow. Vacuum drying is fast and can produce flat, smooth leather by pulling moisture out under reduced pressure, while the hide is held against heated plates. Toggle drying stretches the hide on frames to control shrinkage and maximize area. The factory chooses the drying method based on the final product. Firm leather for structured goods benefits from controlled stretch, while softer leather for garments may prioritize relaxed drying to preserve drape. Asterisk, but dry leather is not finished leather, stiff and uneven until mechanical finishing transforms it. Staking machines flex and knead the leather repeatedly to soften it and break. Stiffness without tearing grain. Milling drums tumble hides to develop softness, create a naturally pebbled grain, and increase fullness. The time in the milling drum is a design parameter. More milling increases softness and texture. But it can also highlight scars and marks. So luxury bison is often milled strategically to balance rugged character with refined feel. Now the surface is engineered. Finishing is a multi-layer coating and curing process that can range from nearly naked, aniline finishes to heavily protected pigmented systems. Aniline finishes use transparent dyes and minimal coatings to showcase natural grain and variation, which suits bison's character but demands cleaner raw hides because defects remain visible. Semi-aniline adds light pigmentation and protective top coats to improve stain resistance without erasing the grain. Pigmented finishes provide maximum uniformity and durability, often used for high-wear items like belts and some bags, but they risk making the leather feel coated if not applied correctly. Finish application is industrial coating technology. Spray lines apply, base coats, color coats, and top coats with controlled viscosity and atomization. Roller coaters and curtain coaters can deliver uniform layers for certain effects. UV or thermal curing sets coatings, and curing profiles matter because undercure causes tackiness and scuffing, while overcure can make the surface brittle. Many modern factories shift toward water-based finishes to reduce VOC emissions, which increases the importance of drying airflow and humidity control to prevent blushing. Pinholes and uneven gloss. Embossing is used when the product requires a specific grain pattern or when the factory wants to standardize texture across variable hides. Heated emboss plates or rollers press a pattern into the surface under controlled pressure and temperature. This is not just aesthetic. Embossing can also tighten surface feel and improve perceived luxury consistency. With bison, embossing is often used selectively because the natural grain is part of the appeal and heavy embossing can erase the signature character. Throughout finishing, the factory runs physical tests that directly predict real-world performance. Tensile strength and tear resistance ensure seams won't fail. Flex testing simulates repeated bending so a wallet fold line doesn't crack. Rub and abrasion testing predicts scuff resistance. Water spotting and stain tests verify the finish. System. Thickness and softness are measured so production stays within the brand's specification window. Luxury fashion also demands that the leather behaves well in cutting rooms. So defect mapping becomes a high-tech profitability tool. Large factories use digital hide scanning tables with cameras that map scars, holes, brands, and thin areas. The system grades each hide and generates a digital cut plan, so the best areas are reserved for visible panels. While less perfect zones become smaller parts, this is how bison leather stays profitable. You're not eliminating natural marks, you're allocating them intelligently. Traceability follows the hide through every operation. Each hide or batch is tracked from receiving through tanning recipes, dye lots, finish lots, and test results. If a customer later reports color shift or peeling, the factory can trace back to a specific top coat batch, cure profile, or fat leak ratio. That feedback loop is what separates a craft tannery from a large, luxury-capable factory. The environmental system is a factory within the factory, because tanning generates high-load wastewater and solid byproducts. Soak and liming liquors carry salts, proteins, and sulfides. Chrome tanning requires chromium management, and modern plants often run chrome recovery, where spent tanning liquor is treated to precipitate chromium for reuse, reducing both cost and discharge. Wastewater passes through screening to remove solids, dissolved air flotation to separate fats and proteins, and biological treatment to reduce cod and bod before discharge. Odor control and air handling matter too, because sulfide gases and solvent vapors must be captured and treated for worker safety and compliance. Solid byproducts are handled with the same efficiency mindset. Hair, fleshings, and trimmings can be rendered, composted, or used in collagen and gelatin production, depending on local infrastructure. The goal is not only waste reduction, but process stability, because leaving organic waste around a tannery attracts pests and increases microbial pressure. When the leather is finished and approved, the factory often supplies it in sides, panels, or pre-cut components. If it's integrated with a fashion workshop, the line continues into splitting into panels, skiving edges for folds, and sometimes pre-finishing edges for high-end goods. Skiving machines shave thickness at fold lines so wallets and bags close cleanly without bulky seams. Edge paint systems apply flexible coatings in multiple layers, with drying between coats, because luxury is judged at the edge more than anywhere else. The reason bison leather becomes luxury is not because it's rare, it's because it's controlled. The factory takes a hide with extreme natural variability and uses measured chemistry, precision thickness control, climate-managed drying, and engineered finishing layers to deliver consistent feel and performance, while preserving the rugged grain customers want. At scale, that's high-tech manufacturing, turning biology into an engineered material, and turning that material into a predictable input for fashion that will be handled, flexed, and judged in millimeters for years,